Hello everyone, this is Doug, and in this video I'm going to introduce how to name aldehydes to you. We're going to go over a few relatively simple examples just to get you started. Do recall that aldehydes, right, are in the carbonyl family. Specifically, aldehydes have to have one H attached to that carbonyl carbon. Right? In a previous video I had two carbons attached there. That was a ketone. If there are other things, it might be an amide or an ester or something like that. But aldehydes specifically need one hydrogen attached to that carbonyl. So that's the functional group that we're going to name today. Now, if you look at naming aldehydes, right, for aldehydes, what you do is they do change the parent name. So if you start off with something that's just a propane, let me erase that. If you start off with something that's a propane, the idea is that you need to drop that E and change it to Al. So here we'd have propane. We're going to drop that E and change it to Al, so we have propanal. So we change it to Al. So this would be propanal. Because, right, we have 1, 2, 3, 4 carbons, and we have an aldehyde on this molecule. So carbon 1, carbon 2, carbon 3, hence the prop. And that's the big idea. What's kind of convenient about aldehydes is because they have to be at the end of a chain, right? If a chain kept on going, it'd be a ketone. Aldehydes are at the end of a chain, so you don't ever have to say like one propanol. You don't have to say where they start because it's kind of implied. Any molecule that has an aldehyde, that's carbon number 1, right? So carbon number 1 is always where the aldehyde is. So this would be carbon 1, 2, 3, 4, 5, 6. This would be carbon 1, 2, 3, 4, 5. And carbon 1, 2, 3, 4, 5, 6. In this case, we have 8 carbons. And then to name them, we just do our normal sorts of naming systems, right? So this is 6 long, so it would be a hexane normally. But since it has an aldehyde, it's hexanal. Hexanal. Again, hexane with the E at the ending, but you change the E to Al, so hexanal. If you have things on there, then you just do the same normal rules, right? So I have 2 methyls at 3 and 4. So then this would be 3,4-dimethyl. In this case, it's 5 carbons for the parent, so it would be pent, so pentanal. And again, notice, right, that I did not have to say where the aldehyde was. You don't need to say 1-pentanal because it's implied. That wherever that aldehyde is, that's number 1. Lastly, I have this octanal. I just have a bromo at carbon number 2, so 2-bromo. 2-bromo, octanal. So 2-bromo, octanal. And that's it. I mean, that's really the gist for naming aldehydes. Then we can just add, it only gets more complicated if you add more functional groups. So let's take a look at a few of those. So here we have a few examples that are a little more complicated. Some of these have multiple functional groups. The first one doesn't really. If I look at my first one here, I actually have 2 options for where I'm going to go. I know this is definitely carbons 1 and 2 because that's where my aldehyde is, but I can go to the right to get 5 carbons, or I can go up to get 5 carbons. And I don't know if you remember, but if you have a tie in terms of carbon lengths that involve your highest priority functional group, you always pick the one that will give you more substituents. So if I go all the way to the right, I'm going to name that top thing as an isopropyl. If I go up, though, I am going to name a methyl and an ethyl. I'm going to have a methyl and an ethyl on here. So my parent is actually going to be this chain right here is the idea. Because that'll give me, like I was just saying, a methyl substituent and an ethyl substituent. And then we just name it so, right? So ethyl comes first because E comes before M. So 3-ethyl, 4-methyl. And this is 5, so I'm using pent, so it's a pentanal. Where it would be pentane, but you change the E to an Al, so pentanal. That's how you would name that one. For the one on the right, what's kind of interesting about this one is that we actually have 2 functional groups, right? I have an aldehyde on there, and I have an alkene. But so since alkenes have a much lower priority group than aldehydes, I'm just going to ignore the alkene basically as far as numbering goes. So I'm just going to go with my numbering based on where my aldehyde is. So that's my carbon 1, that's my 2, 3, 4, and 5. And if you look at these names, right, normally if it was just a hydrocarbon here, we would name this pentane. But it's not a pentane, obviously. We've got these 2 functional groups on here, so it's got an alkene in it. And if I want to take the alkene into account, right, you start with the carbon that it starts at. So this is a 2-pentene or a pent-2-ene. So I'll put pent-2-ene. But I haven't mentioned the aldehyde yet, so I have to change it yet again. The aldehyde, right, we changed the E to an Al. So now this is a pent 2-enal, a pent-2-enal. Or you could say 2-pentanal. But what's important here, right, is that you have that ene in there, because the ene tells you that it's an alkene, that there's an alkene in there, and then the 2 tells you where that alkene is, right? It doesn't start at carbon 3, it doesn't start at carbon 4, it starts at carbon 2. So either one of these names would be fine by me. Again, the first one, since the locant's right in front of the functional group, is technically a little more right with IUPAC, but again, you see both of these approaches for naming all over the place. So that would be 2-pentenal or pent-2-enal. The last one's a little more complicated because I have multiple functional groups in here. I have not only do I have an aldehyde, but I also have a ketone. So I do have a ketone, and I have an aldehyde. Now you'll note, right, that I have aldehydes here as a higher priority than ketones. They are a little higher priority. So my aldehyde is going to be the thing that determines my numbering. So I'm going to say number 1, number 2, number 3, 4, 5, and 6. So I have a hexanal. My parent chain runs like this, like I just drew it. So I do have substituents. I have a phenyl substituent here. That's a phenyl substituent. And then the question becomes, what do I do with this? How do I talk about my ketone? I'm not going to have an own al, because the own is an ending of the parent name. Al is the ending of a parent name. And so the two can't combine. I'm not going to have an own al or something like that. What happens is, instead of saying an own in the parent, we call any carbonyl in a chain an oxo group. So these are actually called oxo groups, OXO. So that's an oxo group. It's analogous to when we had alcohols, right? We used to change the ending of the parent name to OL for, like, butanol. But when alcohol is no longer the highest priority group, we don't call them alcohols. We refer to that OH group as a hydroxyl group. And we say that it's a hydroxyl group, like a 3-hydroxyl, a 4-hydroxyl. We're going to do the same thing with this, where this ketone group, this carbonyl here, is actually going to be an oxo. And we're going to call it a 3-oxo because that's the carbon that it's on. It's on carbon number 3. So I have an oxo group and I have a phenyl group. And if you go through your alphabet, right, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, oxo comes before P, so I have to name that one first. So it looks like I have a 3-oxo, 2-phenyl, 1, 2, 3, 4, 5, 6, hexanal. Right, hexanal because it's a 6-membered aldehyde. There's a phenyl group coming off of carbon number 2, and I say oxo to represent where that ketone is at number 3. So if you see oxo, usually that's talking about a carbonyl, and you just put a carbonyl wherever it's supposed to be. So if you see like an aldehyde and ketone together, that's how you approach it. So hopefully you have a little better idea of how to name aldehydes, hear how they fit in with the ketones and alcohols and alkenes and stuff like that. Definitely do a lot of practice in the book and everything, my practice materials that I give my students. If you have any questions or comments, you can leave them down below, or my students can just email me. Happy studying.